In this video, we're going to review operations with imaginary numbers by hand and in the calculator. So let's look at the first problem. We have just a basic subtraction problem. Now remember that when you're subtracting imaginary numbers or complex numbers, you add and subtract the like parts. So I have the real number part and then the imaginary number part. So I'm going to do 2 minus 5, which would be a negative 3. And 3i minus a negative 3 would be a positive 6i. Now in the calculator, just so you can follow along with me, this is your screen on your calculator and here is your keypad. Okay, so watch over here for the keystrokes. Okay, so always use parentheses when dealing with imaginary numbers. So I'm going to have parenthesis 2 plus 3, and your I is located in blue or possibly yellow above your decimal place. So that means we're going to use the second key and we get I, close parenthesis, minus parenthesis 5 minus 3, I, and then we just hit enter and it gave us the same value by hand, negative 3 plus 6i. Okay, so let's look at problem number 2. Now multiplication is the same. The process is the process is the process. So you can either use the FOIL method, first, outer, inner, last, or you can just use distributive property. So we're going to multiply. Notice there's no operator between them, so that indicates multiplication. So I'm going to do a negative 2 times 5 is a negative 10. A negative 2 times negative 4i is a positive 8i. So then I'm going to go to my second term. 3i times 5 is a positive 15i. And 3i times negative 4i is a negative 12i squared. Remember that even though that's an imaginary number, it's still a variable. So anything times itself is still represented as I squared. So we're going to combine like terms. So we have negative 10. 8i plus 15i is 23i. Now remember that I squared, that I represents the square root of negative 1, so that if we have I squared, that is the square root of negative 1 quantity squared, which is just negative 1. So I'm going to replace my I squared with negative 1. So I have negative 10 plus 23i plus 12. Negative times a negative is a positive. So I'm going to combine like terms, and I get 2 plus 23i. Now remember, it is imperative that you write this in a plus bi form so that the imaginary part is always second. So to take a look at our calculator, we're going to do parenthesis, negative, make sure you use the negative key and not the minus, plus 3i, close parenthesis, times 5 minus 4i, and we get 2 plus 23i. The same answer. Okay? Number 3. Now the problem with this is you have an imaginary in the bottom, and just like a root, we don't leave those in the bottom. We do what we call rationalize. And you do the same way with an imaginary as you would do with a radical. You multiply by the conjugate. So remember, with the conjugate, the first and the second term stay identical. You only change the sign between them. So I have 4 plus 2i. Remember that for equality, we multiply the top and the bottom because anything over itself, no matter how complex, is still 1. Okay, so I'm going to distribute 3 times 4 and 3 times 2i. So I have 12 plus 6i all over. So again, we're going to do that FOIL method or distributive property. But remember, conjugates have something special that happens. Remember, the O and the I in FOIL will always be the same value or be opposite values because it's going to go to 0. So we'll do distributive property. 4 times 4 is 16. 4 times a positive 2i is a positive 8i. Negative 2i times 4 is negative 8i. And negative 2i times positive 2i is negative 4i squared. Now again, notice that the O and the I are the same term, just opposites, so they're going to go to 0. So 8 minus 8 goes to 0. So I have 12 plus 6i over 16 minus 4, and again we're going to replace that I squared with a negative 1. So I then have 12 plus 6i over 16 plus 4. So I have 12 plus 6i over 20. This will all reduce by a factor of 2. So I have 6 plus 3i over 10. Now a lot of times, even though some of your algebra teachers will accept this answer, usually in college algebra they want you to break it apart in the a plus bi form. So that would be 6 over 10 plus 3 over 10i. And notice that this now will reduce further by a factor of 2. So 3 over 5 plus 3 over 10i. And this is actually the value we'll get out of the calculator. So they are absolutely equivalent, just look a little bit different. Okay, so we're going to go to our calculator. I'm going to do 3 divided by, again, parentheses are vital, 4 minus 2i. And then I'm going to hit enter. Now notice we have a problem because we have decimals. So that's an easy problem to fix. You're going to go over here to the math key and you want to select 1 because you want it to turn our answer into a fraction form. And we have our answer, 3/5 plus 3/10 I. 3/5 plus 3/10 I. Okay, number 4 is the exact same setup. The only difference is we have an imaginary on top as well. So we're going to multiply by that conjugate again. Okay, so we're going to have to distribute in the top and the bottom or FOIL. So 2 times 3 is 6. 2 times 4i is 8i. Negative I times 3 is minus 3i. And negative I times 4 is negative 4i squared. All over. So I'm going to have 3 times 3 is 9. 3 times 4i is a positive 12i. Negative 4i times 3, negative 12i. And negative 4i times 4i is negative 16i squared. So we need to do some cleanup. So I'm going to have 6 like terms. 8i minus 3i is positive 5i minus 4. And I'm going to go ahead and replace that I squared with negative 1 all over. My center terms cancel. 9 minus 16 times negative 1. So I have 6 plus 4, which is 10, plus 5i over 9 plus 16. So I have 10 plus 5i over 25. This will all reduce by a factor of 5. So I have 2 plus I over 5. Again, this is acceptable in most high school courses and college algebra. They're going to want you to break that apart into 2/5 plus 1/5 I as your final answer. Okay, so let's go to the calculator. So again, parentheses are vital. 2 minus I divided by 3 minus 4i. Enter. Again, we get those decimals, not a problem. We go to math, go to number 1, and hit enter. 2/5 plus 1/5 I. Exactly what we got by hand. Okay, number 5. Now this one sometimes throws students off because there's not a conjugate. But that's fine because we're going to multiply by I because we know that the quantity I times I is I squared and that I squared is negative 1. So again, we have to multiply top and bottom. So I have 2I over I squared, which is 2I over negative 1, which is negative 2I. Okay? So again, we're going to go to our calculator and we're going to do 2 divided by I, enter, and it gives you the answer negative 2I. Now with this problem, sometimes if you have an older calculator, you can get a little bit different answers, so don't be alarmed if it looks slightly different from mine. Okay. Number 6, I teach this as multiples of I squared because we already know what I squared is, so there's no purpose in memorizing up to I to the 4th. So I'm simply going to write this in terms of I squared as a power to a power because I know the value of I squared. So then the question becomes 2 times what will be 12, because in a power to a power we multiply. That would be 6. So these two are equivalent statements. Now I can easily replace I squared with -1 to the 6. Now this can be put in the calculator, or you can remember that an even power with a negative base will result in a positive answer. A negative base with an odd power will result in a negative answer. So this would just be +1. So again, we can go to our calculator and we're going to do parenthesis. Well, you don't have to do parenthesis. I raised to the 12th power, and I get 1. Again, with this problem, if you have an older model calculator, sometimes if it's a negative I or a positive I, sometimes you may get a long string that is a very small number, very close to 0. Okay? So we also got +1. So what happens if it doesn't go in evenly? That's an easy enough fix. We can use 2 laws of exponents. We can use the power rule and the product rule. So power rule says that when I have a power to a power, I multiply. So the question is, how close can I get to 35 without going over? Because 35 is definitely not evenly divisible by 2. So that would be 17, because 2 times 17 is 34. So I'm not quite there yet because I need 35. But product rule says when I multiply like bases, I add their exponents. So this would be 34 by multiplication plus 1 would be 35. Okay? So now I can replace I squared with -1 to the 17th times I. And again, that negative base to an odd power will result in a negative answer. So I have -1 times I, which is just -I. So again, we can view that in the calculator as I raised to the 35th power, enter -I, just as we got by hand.